Everyone. So I thought we could start with the calendar since this is the first lesson of the unit. Just give you an idea. So we have a lesson today, which is Friday, which is on inverse functions. And then I want to kind of point out to you a couple things. So next week we're going to have lessons Monday, Tuesday, Wednesday. Thursday we'll do kind of like a review and have some homework. We don't have school next Friday. And then the following week, notice that we have a full 5 days worth of lessons. We're graphing on 2 days. We have change of base on Wednesday. We're going to expand for 2 days. And then we're going to come to the following week, and this is when we're going to have a quiz. We would have quizzed on Monday, except then we have some shortened periods for a couple of my classes. So we will flip-flop. We'll learn a new lesson on Monday. You'll work on the quiz review at night. You'll have it over the weekend, which is kind of nice. And then we'll quiz on Tuesday, and we will continue back on the next day with solving logs. Okay? And then we'll have a couple more lessons after this where we have some applications. And then this will take us into the last week of school before we go on spring break. So we're actually going to test on 2 days again. On applications the first day, which will be a little bit shorter of a test. And then the Friday we'll test on the non-applications, and then that will take us right into spring break. So it'll be a nice clean finish before we leave, and then we come back and we'll be able to start fresh with a new unit. Okay, but I did want to kind of point out again that if you look at this, we have a long ways before we have a quiz. So we'll have this Friday lesson, we'll have this whole week right here, and then we'll have this whole week. So we almost have 2 full weeks before we have a quiz. Okay. So, alright, so let's talk about our first lesson, which is inverses today. Inverses, there's a couple ways that you can approach inverses. We can approach inverses as coordinates, like we have in number 1, or we can approach inverses like we have in number 2 as a graph, or we can approach inverses as a function, which we'll do after these two. So, inverse functions means that the points are flip-flopped from each other. So if these are your ordered pairs, go ahead and graph all 5 of these coordinates, and then double check to see that you graph them correctly. Okay, so it should look like this. We're not going to connect them. It's not a function. It's just coordinates. Okay, the inverse of these coordinates just means that you flip-flop their order. So instead of -4, -3, write down -3, -4. And then -2, -4 becomes -4, -2. Notice that I'm not changing any positives to negatives or negatives to positives. That would be opposite. Inverse just means we flip-flop their order. So then this becomes -2, 0. This becomes 0, 1. And then this one becomes 3, 2. Okay, so go ahead and graph those. If you have a different color, it'd be kind of nice to point out the different functions. Alright, so -3, -4. Oops, definitely graphed those in the wrong place. Alright, you can see that right there. So the green part is the inverse, and the orange part is your original. Okay, so the way that we know that it is an inverse function is if you draw in this diagonal that goes in, starting from the origin, hits all these corners. This is the line y equals x. Something is an inverse function if it is reflected over this line. So notice that if I take each of these coordinates, notice that it is perpendicular. As I draw from point to point, it's perpendicular to that line y equals x. Perpendicular, 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 perpendicular. That means that this is an inverse function. Okay, so let's try again over here. Notice that this function is already graphed. Okay, so this coordinate right here is at 0, 1, which means then its inverse would be at 1, 0. So I'll plot the point 1, 0, which will go here. This coordinate is at 1, 2, which means that its inverse is at 2, 1 here. This orange coordinate is at 2, 5, which means its inverse is at 5, 2. Okay, notice that this function is going like this. So notice your asymptote right here. Remember, if you think back to exponential functions, there's an asymptote that goes right here that this line is approaching but not touching. So if all the coordinates get flipped, then that means its characteristics gets flipped as well. So that means its asymptote, instead of being horizontal, if we flip it, becomes vertical. So that means now the asymptote would actually go like this. And so when I connect my function now looks like this. Okay, and I can see that it's an inverse function because, again, if I draw this line, y equals x, so this diagonal line, so this is y equals x. This is what helps me determine if it's an inverse function. If I go point to point, point to point, point to point, notice that as I cross, there's that perpendicular line. Okay, we're going to label this as my original function, so this is f of x, and this is my inverse function, and the notation is f to the negative 1 of x. So that's the notation for inverse. Okay, we just want to make sure we note which one's inverse and which one's my original function. Okay, so we had, in number 1, we had points. In number 2, we had a graph function. In number 3, in the next couple examples, we're actually going to graph both of the functions based off of the equation. Okay, so it says graph f of x and f inverse of x. I'm going to graph the function that we have first. So this is a linear function. Remember, this right here is your y-intercept. So that means start at the height of 6 on your y-axis. 3/4 means that's your rise over run. So go up 3 over 4. And draw everything that can fit on your graph. Go down 3, left 4, down 3 again, left 4, and then if we connect those, that's my f of x, that's my function. So I'm going to say that this is f of x. Okay. I could graph the inverse function based off of these coordinates. I could flip their order, so meaning like this point right here is at negative 8, 0. So if I flip that, I'd be at 0, negative 8, which would be down here. If I flipped this coordinate, it's at negative 4, 3. So then I would go to 3, negative 4. This coordinate is at 0, 6. So I would go to 6, 0. This coordinate is at 4, 9, so I would go to 9, 4, and then I would connect these, and then that would be my inverse function. So f to the negative 1 of x. Again, we always want to label which one is which, and again, I know that this is my inverse function because if I draw in this dashed line, I can see that if I draw from here to here, it's perpendicular over that line. So is it here, here, and here. Okay, now we do need to find the inverse of this function as well, and then we'll double check that that graph is actually right, even though we already know it is. When we find the inverse of a function, just like we did with our coordinates and how we're flipping the order, we flip our variables. So f of x is y, and here's my x. So if I flip their orders, then y becomes x, and x becomes y. Okay, which if you think about it should make sense because when we're up here, we're saying this is x and this is y, but when we flip them, that's our y and that's our x. So notice that the order flips. Okay, and then what we do is we isolate and we get y by itself. So I would subtract 6 and I would have x minus 6 equals 3/4 y. If I want to get rid of the 3/4, I'm going to multiply by the reciprocal, so 4/3. I need to make sure I take this whole side and multiply by 4/3, which I will have to distribute in. Notice that I just got y by itself, so I'm actually going to write y equals, okay, 4/3 times x is 4/3 x, minus 4 times 6 is 24, divided by 3 is 8, so this is negative 8. Okay, that is my inverse function, but I always wanted to have the right notation. So I'm going to say the inverse of x, so f to the negative 1 of x equals 4/3 x minus 8. So this is the answer that we were looking for. The inverse function is 4/3 x minus 8. And if I look at my graph, negative 8 is my y-intercept. Notice that's where my y-intercept is. In this one, my slope is 4/3. So notice I go up 4, right 3, up 4, right 3, up 4, right 3. Okay, so here's my inverse function, and here both of them are graphed. All right, we're going to do this with a couple different functions. So this was a linear function. Okay, now let's try it with a different function. So this one is quadratic. Okay, so I'm going to graph this first. If this is x squared minus 5, then that means my y-intercept is at 0, negative 5. If I substitute in 0, 0 squared minus 5, so my y-intercept is at 0, negative 5. Okay, if it's x squared, so now that I moved, I can graph, oh my goodness, I can graph it using my a value. So I can graph it using 1x squared. Okay, so what that means is, remember, x is your movement left or right. So that means I will move left or right, I will square it and multiply by 1. The 1 doesn't matter. So if I move right 1, 1 squared is 1. If I go back here and I move right 2, 2 squared is 4, so I go up 4. If I move right 3, 3 squared is 9. If I move right 4, 4 squared is 16, which doesn't fit. So, symmetrically, I know that this is a point, this is a point, and that's a point. So if I connect and extend beyond so that I can say this is f of x. So that's my function. Okay? Now I need to find the inverse of the function. So the inverse means that I'm going to flip-flop the variable. So again, that's y. So that changes to x equals y squared minus 5. Okay, so anytime you want to find the inverse, flip their variables and then solve. Okay, I want to get it back equal to y. So I'm going to add 5, which gives me x plus 5 equals y squared. If I want to get y by itself, I take the square root, which means I got y by itself, so y equals, when I take the square root, I have a plus or a minus, and the square root of x plus 5. Okay, but here's the catch. I don't want a plus or minus square root of 5. My inverse function, so f to the negative 1 of x equals, I can pick which one. Do I want the positive or do I want the negative? It's easier just to take the positive. So I'm going to say I want the square root of x plus 5. So this is my answer. Okay, here's why I only want one of them. When I want an inverse function, I need to make sure that it's actually a function. So, watch what happens. If my original function looks like this, and I were to take all of these coordinates and flip them, this is 0, negative 5 would move to negative 5, 0, and then my u would go like this. Okay, the problem is, in order to be a function, you have to pass the vertical line test. But if I draw a vertical line in, I hit here and here, so it does not pass. So it does not pass vertical line test, which means that it's not a function. So, but I want it to be the inverse function. So what I do is I get rid of half of it. So if this is the vertex and this is where it starts, I can get rid of this and then just make it this part right here. And then that's still, now it's a function because there isn't this bottom part. Okay? So when I go to graph it, I'm just gonna flip these, or I can think about it this way too. If this says x plus 5, the opposite of 5 is negative 5. So negative 5, 0 is right here, which makes sense because that's the opposite of this. Okay, and then from here, I'm going to do the square root of x. So I'm going to say, okay, if I move right 1, the square root of 1 is 1. If I move right 1, now I don't want to move right 2 because the square root of 2 is not nice, square root of 3 is not nice, but the square root of 4 is 2, so I can go up 2. And then 5 is not nice, 6 isn't nice, 7 isn't nice, 8 isn't nice, but 9, the square root of 9 is 3, so I move up 3. And I go 10, 11, 12, 13, 14, 15, 16 will be my next one, but it's off. So then this will be my function. But I could also look at my coordinates and flip them too. Notice that this coordinate right here is 1, negative 4, and this coordinate is negative 4, 1. Okay, so different ways that you can approach it. This I want to then label as my inverse. Okay, you need to make sure that you always label which one's f of x and which one's the inverse of x. Okay, here's the other catch. Because we had to get rid of the graph, we had to restrict the domain. And you guys need to change this on yours. We're restricting the domain of your original function, not the inverse. So when it says what is the restricted domain of your f of x function, when you look back at your original function, we're only taking this part of my function. We're taking this domain. That's what made up this green inverse. Well, the domain of that is my x value starting at 0 going towards positive infinity. So that means my restricted domain is from 0 to infinity. And I want to take 0. We never include infinity. The only time that you ever have to worry about a restricted domain is when you deal with something that has an x squared or an x to the 4th or an x to the 6th, anytime you have an even exponent. Okay, so it's nice. It doesn't happen in linear. If we look at the next part, or the next graph, we have a cube root, which is nice because we don't have to worry about a restricted domain either. Okay, so if I were to graph this, notice that there's nothing happening in here, so this means that I'm at 0, 0. I didn't move left or right, I didn't move up or down. This kind of goes back to why we had talked about what we did in the last section of the last unit. So if I graph 0, 0, I'm here. Okay, and then I would just evaluate. So I'd move right 1, and the cube root of 1 is 1. The next number that I'd want to take the cube root of is 8. Because if I move 8, the cube root of 8 is 2. Okay, so meaning what times itself 3 times gives you 8. But with the cube root, I can go backwards too. If I move -1, the cube root of -1 is -1. Okay, because what times itself 3 times is -1 gives you -1. I can also move backwards -8 because the cube root of -8 is -2. Because -2 times -2 times -2 gives you -8. Okay, and then this would be my graph. I'm going to extend it out so that way I can say that this is f of x. Okay, my inverse function means that now I need to undo this. So I'm going to say x equals the cube root of y. Notice I flipped the variables. And now I need to solve. Well, if I want to get y by itself, I'd cube this to get rid of the cube root, which means I have to cube this. I just got y by itself, so it's y equals x cubed. So when I actually state my function, I'm going to say the inverse of x is x cubed. So that's my answer for the inverse function. Now I'm going to graph that. Okay, so this one didn't get moved left or right or up or down. If it did, it would be something like this. And then we would say right 3, up 7. Okay, so just so you can see. Alright, so then I'm going to plot the point 0, 0. Okay, if I move right 1, 1 cubed is 1. If I move right 2, 2 cubed is 8. Notice that whatever I move, I'm performing the operation. And then I can move left 1. -1 cubed is -1. -2 cubed is -8. So I get this function. So if I connect, it looks like this. And I'm going to state that this is my inverse function. Okay, again, always state which one is which. And then notice if I were to draw in this diagonal line like how we had started, that these are in fact, or this is in fact an inverse, because if I were to draw from here to here, it's perpendicular over that line, those are perpendicular, and so is that. Okay, I'm going to erase that, but you can see that it's perpendicular. I'm going to leave that line in just so you can see. Okay, so let's keep going. Alright, now we want to find the inverse of a cubic function. So we're cubing right now. Okay, I'm going to start by graphing this first. So the coordinate would be at 1, -5. So opposite and the -5. So if I plot at 1, -5, I'm here. And then once I plot that point, I just need to pay attention to that x cubed. Notice that's a 1 right here. So that would be 1x cubed, which just means when I move, I cube it, multiply by 1. So if I move right 1, 1 cubed is 1. If I move right 2, 2 cubed is 8. and then I'm going to run out of space because 3 cubed is 27. If I move left 1, negative 1 cubed is negative 1. And then negative 2 isn't going to fit. It's going to be somewhere down here, but that will help me graph it. I know it's got to look like this. Okay, so this is my function. If I want to graph the inverse, I could take these points right now and flip them, so I'm going to show you that. So if the starting point was at 1, negative 5, then I would go to negative 5, 1, which would be here. This point was 2, negative 4, so that would be negative 4, 2. This point is at 3, 3, so then if I flip 3, 3, I still get 3, 3. This point right here was at 0, negative 6, so I'd go to negative 6, 0, and that would be my function. So my function now looks like that. And this would be my inverse function. Okay, if I wanted to check to make sure, I draw on this dashed line, which is y equals x. So this is y equals x. Notice that as I draw from point to point, that these are all perpendicular over that line. This because it's there. Okay, I'm going to erase that just so it's not too confusing, but that's the idea. Okay, now I still need to find the new function. Alright, so when I go find the new function, again, I'm going to switch. So this is x equals y minus 1 cubed minus 5. Okay, I'm going to add 5, so x plus 5 equals y minus 1 cubed. In order to undo the cube, I cube root. Okay, so I get the cube root of x plus 5 equals y minus 1. Add 1 to both sides, it's going to get y by itself. So it's going to be y equals the cube root of x plus 5 plus 1. So I'm adding that 1. Okay, then I need to write it in its correct notation. So I'm going to say the inverse of x is equal to the cube root of x plus 5 plus 1. Okay, it's very important that we have the correct notation. If we say y equals, then it's not clear whether it's the original function or the new function. Okay, and then I can check my answer. If this is at plus 5, that means then the point should be at negative 5, 1. And if I look on my graph, there's a point at negative 5, 1, and that is the vertex, or the critical point. Okay, and then I would perform the cube root. So I'd be paying attention to every time I move, I would do this. So from here, if I move right 1, the cube root of 1 is 1. If I move right 8, the cube root of 8 is 2. So you can see that that's correct. Okay. All right. On the back of your notes, you should have a blank sheet. So I wanted you to write this down right away. So think about this. We started with a linear function. Let's write this down. So our f of x, and then our inverse. So if we started with a linear function, our inverse was a linear function. If we started with a quadratic function, so I'm just actually going to write x squared. So if we start with the quadratic, which is x squared, then the inverse would be the square root of x. If we started with x cubed, our inverse is the cube root of x. Okay? The point of this is you should be seeing why they're inverses. Because in order to undo x squared, we square root. In order to undo a cube root, or a cube, we cube root. So then if we start with a square root of x, then in order to undo it, we would square, meaning the inverse function is x squared. If we start with a cube root of x, in order to undo it, we cube. So the inverse function is x cubed. Okay? So that should give you a good idea of why the inverse is what it is, because the inverse just means what's undoing it. Okay? So let's go back to our notes and finish. If I look down here, these functions are graphed, and it says, does the graph show inverse functions, why or why not? Well, the thing that we keep talking about is whether the points are perpendicular over this line, y equals x. So that's what we want to determine. If it is, then it's an inverse. If it isn't, then it's not. if you look at this, if I were to draw in the line that's y equals x, and I were to say, okay, well, these points are opposite, they're not even reflected over the line, let alone perpendicular over it as I do that. So this is not an inverse function. And also, if you look a little bit closer, we can see what actually happened. If you notice, this point and this point match up, this point and this point match up, these 2 points match up, this point and this point, these 2 points match up, and these 2 and these 2. So what happened is this actually got reflected over the x-axis. From here down, from here down, from here it's on a line, from here down, from here down. So no, because we're going to say not reflected over the line y equals x. And then I'm going to put in parentheses that it is reflected over the x-axis, which doesn't mean it's an inverse. It just means it's what it's reflected over. Okay? Whereas if we come over here and we say, okay, again, I'm going to draw this in. So 2, 2, 4, 4, just so I can get the points. So when I connect these, 2, 2, 4, 4. So this is my line y equals x. Okay? When I look at this point 0, 4, and 4, 0, notice that if I connect them, it's perpendicular over that line. Okay, I can connect these two as well. It looks like it's about something there, so it would be something over here-ish. And again, if I connect those, I can see that that's perpendicular over that line. Okay, so we're going to say yes, because it's reflected over the line y equals x. So that right there, it's kind of, this is the test to determine if it's an inverse function. Okay, alright, flip it over, we'll talk about the last page. Alright, so these are some word problems that we have where we're going to talk about inverse functions as well. Okay, it says, Reese is a farmer. She estimates the total number of pumpkins she will be able to harvest based on the number of pumpkin seeds planted. The total number of pumpkins harvested can be estimated using the function f of x equals 2.5x, so a linear function, where x is the number of seeds planted. Reese has at most 1,000 seeds to plant, so that at most is important. Okay, so inverse of a linear function is still a linear function from what we just talked about. So first thing says find the equation of the inverse function. Okay, so this is what we want to do first. Well, that means that I'm going to take this function, I'm going to flip the variables. So instead of y equals, it's x equals 2.5. And I'm actually going to change this 2.5 to 5 over 2. Just because I think whenever we talk about linear, we always want it to be rise over run, which is a fraction. Okay, I'll draw an arrow here. Oops, sorry. This should be y. So 5 over 2 y, because we're flipping the variables. Okay, so now I solve. Well, in order to get y by itself, I'd multiply by the reciprocal. So over here, I multiply by the reciprocal. Well, I just got y by itself, so y equals 2/5 x. So that means my inverse, so we want to use the correct notation. So the inverse function is 2/5 x. So this right here is my answer. That is my inverse function. Okay, notice that the slopes are opposite of one another. Okay. B says, what is the meaning of x in the inverse function? Well, these switch. So whatever x was is now going to get flip-flopped. So I want to go back and determine what x was. So I'm going to highlight these. Notice it says right here, x is the number of seeds planted. So if x represents the number of seeds planted, then in the inverse function, that's your y. So what is the meaning of y in the inverse function? We're going to say number of seeds planted. Okay, so the important thing to remember is inverse switches everything. So if it switches the coordinates, it must switch the x and the y values. It must switch the x and the y meanings on your x-axis. Okay. If I go back up, now I'm going to figure out what y was in the original. So in the original, it says, let's see, The total number of pumpkins harvested can be estimated using this function. So total number of pumpkins harvested, which means if that was my y in the original, now that becomes my x. So total number of pumpkins harvested. Oops. So total number of pumpkins harvested. Okay. What is the domain and range of the inverse function? In order to determine the domain and range of the inverse function, I would always figure out what it is for the original function, and then I can just flip them. So I'm going to say, my domain and my range, and again, I would always do it for the original. So if I look at my original function, domain was talking about the number of seeds planted. And then it says Reese has at most 1,000 seeds to plant. So that means that Reese could plant anywhere from 0 seeds up to 1,000 seeds. So the domain would be 0 up to 1,000 seeds. And she could plant 0, she could plant 1,000, so brackets around both. Okay, now the range is talking about the total number of pumpkins harvested, but the total number of pumpkins harvested is going to be based off the number of seeds. So if x is 0, 2.5 times 0 is 0. So if she plants 0 seeds, she gets 0 plants. Should make sense. If she plants 1,000 seeds, then notice up here it's 1,000 times 2.5. Then she's going to get, let's see, what's 1,000? Okay, so 2,500. So that means if she plants 1,000 seeds based off of this function, she can expect at most 2,500 pumpkins. So the range then would be from 0 to 2,500 pumpkins. Okay, but that's for the original function. So the inverse function, domain and range flip-flop. So the domain was the range. So the domain now is 0 to 2,500. And the range is now 0 to 1,000. Because again, if you look at what we described up above, it says what is the meaning of y in the inverse function, which is your now number of seeds planted from 0 to 1,000 seeds planted. Based off of those seeds, that's what will grow your pumpkins. So this is the answer. You can find it without doing this part up here, but it's a lot easier to do for the original and then just flip them. So this goes here, and this goes here. Okay, the idea with inverse is you really should be seeing is flip everything. Okay, let's try it again. So that was for a linear function. Now the next one is a quadratic function. It says the distance a car travels in meters can be estimated using the equation f of x equals 1.3x squared. Okay, so this is my function, where x is your time in seconds from 0 to 10. Okay, so notice that 0 is less than or equal to x, which is less than or equal to 10. So I would write down interval notation. That means that your x can only be from 0 to 10. Okay, find the equation of the inverse function. Okay, first thing I want to flip-flop the variables. So I want to say x equals 1.3 times y squared. I'm not going to change 1.3 into a fraction because quadratics we don't need y's overrun. Okay, so first thing I'm going to do is I'm going to divide 1.3 by each side, which gives me x divided by 1.3 equals y squared. Okay, y by itself, I'm going to square root, which again should make sense because the opposite of x squared is square root since they undo each other. So then that means that my function is y equals plus or minus the square root of x over 1.3. But remember when we talked about a quadratic, we only want one of these two because of the fact that it wouldn't be a function if we took both. Okay, in the context of a problem, we're almost never going to take the negative because in this case, then it'd be talking about a negative time or distance, which we can't have either. So we'll take the positive and we'll say the inverse function is equal to the square root of x over 1.3. So this is my inverse function. Okay. Same as the last problem. It says, what is the meaning of x in the inverse function? What is the meaning of y in the inverse function? So I would go back and then just identify what they were in the original. So it says x is your time in seconds, which means then that flips. So if x is time in seconds, then that's now my y. So I'm going to say time in seconds. Okay, and in the original problem, let's see, it said the distance a car travels in meters can be estimated using this equation. So the distance a car travels in meters is my y, because that's what my function is representing. So now that becomes x. So distance in meters. So distance in meters. Okay, next question. What is the domain and range of the inverse function? Again, I would figure out what the domain and range is of your original function. It's a lot easier. Well, in my original problem, it said that x is the time in seconds, and it has to be from 0 to 10. So that is my domain. So 0 to 10. So if my domain can only be the values from 0 to 10, then my range is based off of those domain values. So to figure it out, I'm going to substitute in 0 and 10. Well, 1.3 times 0 squared is 0. And 1.3 times 10 squared, so 10 squared is 100. 100 times 1.3 is 130. Okay, and again, I'm substituting in both 0 and 10 because I want to see what my lowest time will be and what my highest time will be. So that means the car will travel between 0 and 130 meters. So my range is 0 meters to 130 meters. I'm including both. Okay, and that means then that the domain and range of my inverse function is the opposite. So the domain is the 0 to 130 because that was talking about the distance traveled. And the range is 0 to 10 because that's talking about the time. Okay, this is what the answer is looking for. This is what helps us get there. Okay, again, range flips, domain flips. Okay, so the big concept in what we learned today is that flipping. Inverse means flipping. Okay, we've done it with coordinates, so just to kind of go back real quick and look at what we've done. We started by saying that if I have coordinates, I just flip-flop the order and graph them. If I have a function, I identify what the coordinate is and then flip it. And then we did a bunch of examples where we had a function, we had to find the inverse and graph both of them. You can graph the original and then take their points and flip them, but you're still going to need to find the inverse function. Okay, a linear, the inverse is a linear. To undo a linear, we do a linear. When we have a quadratic, we undo it with the square root. Because we're square rooting, we have to worry about a plus or minus, which means we have to worry about restricting the domain so we don't end up with a function or something that doesn't pass the vertical line test. When we have a cube root, to undo it, we cube. So a cube root and a cubed function. And then when we have a cubed function, to undo it, we have a cube root function. Okay? And we could continue to undo a fourth root. We raise it to the fourth, vice versa. Okay? Your homework is not as long as the notes, but same ideas. You're going to have some points that you have to find the inverse of. So you'll do that a couple times. You'll have to find the inverse of a function that's graphed. Just identify the coordinates and flip them. And then you'll have a linear function that you have to find the inverse of. You'll have a quadratic that you have to find the inverse of. The only time that you need to restrict the domain is when it's a quadratic or if it was raised x to the fourth. Okay, otherwise you don't need to. You have a cubic that you'll have to find the inverse of. Okay? You have to find the inverse again of a cubic, a cube root. And then you get into some of the word problems like what we just did, and they should model pretty closely. Okay? All right, great. Thank you.